United Arab Emirates, a country suffocating under traffic congestion and unbearable 50-degree heat. This is where the fate of uST String Technologies Incorporated is being decided. Engineers must adapt a prototype of a radically new type of public transport that is capable of literally flying above the road where conventional buses remain hopelessly stuck in traffic. If Belarusian specialists can implement this project in the extreme climate of the Emirates, they will forever change the modern understanding of passenger and freight transportation. Sharjah, United Arab Emirates. On this plot of land, Anatoly Unitsky and his team are preparing to build the Ucarrat transport complex. But for now, they face nothing but a desert strip of sand dunes. The complex will include a boarding platform, 2 passenger stations, an electric vehicle, and a track. It may seem simple.
Upon arriving here, I had to learn many things from scratch. In the Emirates, no one had ever worked with such technologies before.
Nothing difficult, except that a 12-ton bus with passengers on board must travel above the scorching desert at a speed of 120 kilometers per hour while maintaining absolute safety and system efficiency in extreme conditions.
To accelerate that mass, time is needed to reach the design speed. Therefore, a longer track is required.
The engineers are tasked with building the tallest, most load-bearing, and longest track in the company's history.
The higher the speed and the heavier the vehicle, the more power is needed for acceleration. And we cannot change the laws of physics.
To meet these challenging objectives, they will have to rely on all the experience and knowledge accumulated over decades of work in Belarus.
I saw the desert and we somehow got lucky again. There too was a military base. I stood there thinking where to even start.
Construction began in September 2020, when the excavator bucket first pierced the sandy soil, marking the start of a large-scale development. Engineers began soil exploration to accurately determine support locations. The structure had to be erected with maximum precision. To comply with the UAE's stringent construction standards, a decision was made to install intermediate supports as tall as a 5-story building. But from the outset, the builders faced serious challenges. Under the blazing sun, poisonous snakes and scorpions scurried around. Strong, gusty winds from the coast blew away fencing, and equipment repeatedly got stuck in the loose sand. Then you begin to understand what it really means to build in the desert.
We tackled this by using different equipment, locally compacting the soil, soaking it with water, and tamping it with heavier machinery.
Yet the sand still got everywhere. It clogged mechanisms, interfered with equipment, and complicated every stage of construction.
The workers were extremely exhausted. Everyone was drained. But I believe we now need to pull ourselves together a bit and maintain focus.
No matter how much effort it takes the international team of specialists from more than 5 countries under the leadership of engineers from Belarus is determined to work here until Ucarrat becomes a reality.
That's why, back when we were students, we designed the ideal system, which we now call uST. It is ideal from all perspectives, based on the laws of physics, structural analysis, theoretical mechanics, material science, mechanical engineering, paradynamics, ergonomics, economics, and much more. It is an optimal system, designed from scratch, not by improving something existing, offering the theoretically highest possible parameters, maximum efficiency, the best aerodynamics, the lowest resource consumption, the lowest cost, and more.
March 2021. One by one, massive intermediate supports rise above the ground, forming the framework for the future transport system. Strong enough to bear a load of 100 tons and tall enough to fit into the urban infrastructure of any major city in the Emirates. 2 anchor supports have also been built, which will serve as passenger stations. At one of them, builders begin assembling and installing a powerful anchor unit. One side of the rail string track structure will be fastened to it. This anchor unit is designed to hold a tension force of 1,800 tons, twice the weight of the largest Belazid truck, fully loaded.
Preparations for installing the rail string track structure have begun. We see scaffolding here, because the installation will naturally also run over an asphalt road. And so we must proceed in a way that doesn't disrupt traffic.
The next stage is the installation of the elevated track, one of the most complex and critical parts of the project. The engineers faced a difficult task to assemble 54 cables of high-strength steel, each 2,160 meters long, into 2 string rails. To pre-tension them and then lift them onto the supports and secure them.
So we mounted the strings, the load-bearing cables, rails, suspensions, and other elements at ground level.
But how do you lift a pre-tensioned metal structure more than 2 kilometers long and weighing 350 tons to a height of 17 meters without damaging it?
That was the most difficult operation we encountered in the Emirates.
The standard solution would have required 7 cranes, each with a lifting capacity of more than 500 tons, and their rental would have cost more than $35,000 per day. To stay within budget, the general designer came up with a simple but brilliant solution.
We combined 2 technologies. The technology used for laying a main pipeline, a solid welded structure more than 2 to 10 kilometers long, into the ground, and the technology used to lift some local ultra-heavy structure to a height, for example, an oil drilling platform. There they use hydraulic lifters. We positioned hydraulic lifters along the length of our linear structure.
And in the event of, say, a failure somewhere or a cable not engaging properly, the whole thing could have collapsed.
The hydraulic lifters were secured on the supports. After that, we began to raise the entire route in stages. Step by step, under the relentless and scorching midday sun, the dedicated team of skilled engineers and hard-working builders quite literally and painstakingly raised the promising future of their ambitious project to an entirely new and unprecedented level.
By controlling the force in each jack, we were able to lift the track structure to the exact height we needed, to the precise mark. This allowed us to significantly lower our overall costs, especially when compared to using a traditional truck crane.
And no one in the world had ever done anything like this before us. There were certain risks, but we anticipated them and lifted the track structure, securing it without any problems.
This technology deserves to be entered into the Guinness Book of Records because nothing like it exists in road construction anywhere in the world. We were the first.
If it had all collapsed, that would have been the end of us. We would have gone bankrupt and demonstrated the failure of the technology. And it could have happened. Everything was on the edge, as they say.
While the team is busy with the track, in the rolling stock department in Minsk, they're assembling a very special vehicle. An electric car capable of operating flawlessly even in the most extreme heat.
The previous vehicles we built were designed for our mild Belarusian climate. Now we've been given a task where the climate is completely different. It's the tropics, it's a harsh climate. The temperature can reach over 50 degrees in the shade. There's also humidity, a maritime climate, and even desert and sand. In short, it's not an easy task.
Imagine there's some emergency situation and the vehicle gets stuck. It's hanging there somewhere under the sun for half an hour. In an hour and a half, everyone inside would just suffocate and roast, all the passengers.
Today, the engineers are starting to install the traction module. This is the key component that enables the vehicle to move. The traction module is carefully secured so that the structure doesn't sway. There's no room for complacency. Every part must be installed perfectly. After all, the carriage is facing a serious test ahead. Special attention is paid to the electrical system. Even a minor short circuit at high temperatures can trigger a fire and cause system malfunctions. The main goal is to create a reliable vehicle and prepare it for operation in extreme conditions.
When the machine was already assembled, standing in the workshop, ready, you come up to it and it looks like a Titan. This is truly the biggest machine we've ever built.
This electric vehicle incorporates the company's best engineering solutions and has been named the Unibus Ucarrat U4-212. It is equipped with a powerful air conditioning system, a two-stage pneumatic suspension, energy autonomy, and advanced safety systems. Even in hot conditions, it remains comfortable and economical. The Ucarrat's energy consumption is 4 times lower than that of a bus with the same passenger capacity. But can the Ucarrat compete not only with buses, but also with the most familiar type of urban transport, like the subway?
If we succeed, this will be the cheapest alternative to the subway. 1 kilometer, just 1 kilometer of our track structure costs about 5 million. And for the subway, the numbers start at 80 to 100 million per kilometer.
Sometimes they have to carve a tunnel through solid rock underground with a diameter of 9 to 12 meters just to build a subway tunnel. Can you imagine how difficult and insanely expensive that is?
If we compare our system to the Timmins Metro in Dubai, the difference in the cost of the span structure is obvious. And also in the use of modularity in our vehicles. That is, at any time, we can add or remove part of the rolling stock from the depot. And for us, this happens quite quickly thanks to our control systems.
Few people have heard of it, but according to experts, passengers of the future will head to Ucarrat station instead of the metro station. If this prediction comes true, Ucarrat could turn into an independent industry.
This is one of the models of the Retromobile, a driverless rail-based retromobile on regular wheels. What's important? Driverless means no driver, no problems with the human factor. Rail-based means it runs on rails. On steel wheels, because you can also run on pneumatic wheels on rails or on polymer wheels, but specifically on steel wheels, because this minimizes the energy costs for wheel rolling.
However, in order to become the transport of the future, Ucarrat must undergo a series of tests. One of these is the electromagnetic compatibility test. We check to ensure that the Unibus is resistant to external electromagnetic interference, for example, when passing near power lines. Also, we make sure that the Unibus's own systems do not create critical interference for the operation of other equipment, such as the station control system or cars passing near the Unibus. The traction module of the Ucarrat is placed in a special radio-shielded chamber. Then the steel doors are closed. Inside the chamber, a powerful artificial Electromagnetic field is generated, affecting all the module's electronic systems. The progress of the tests is monitored from the control room. All parameters are within acceptable limits. The Unibus is safe for operation within the complex, resistant to various external influences, which also increases its safety. It is safe for the infrastructure where the complex is located. Everything was within the range of regulatory documents. Passing the test in the radio-shielded chamber was the easy part of the program. The difficult part is transporting the carriage 4,000 kilometers from Minsk to Sharjah.
At first we wanted to deliver it by plane, but unfortunately, due to the large dimensions and heavy weight of the cargo, it wouldn't fit into any aircraft except perhaps a military transport IL-76. But there was another problem. Such planes charge very high fees for delivery. It would have cost about €250,000, so we decided to ship it by sea.
The engineers are hurrying to get the carriage on track for the upcoming meeting with potential clients. Divided into two separate modules, it is placed on two cargo platforms and leaves the assembly shop. Ahead lies a journey by rail to be loaded onto a ship in the port of Klaipėda. But no one suspected that it would arrive in the Baltic Sea 30 days behind schedule. The escalating geopolitical situation disrupted all deadlines and put the entire project at risk.
It was very stressful because it was right before New Year's and there was a heavy workload. We no longer considered using an airplane since the cargo wouldn't fit. Rail transport was chosen as the more reliable option. But unfortunately, problems arose there as well, because the railway never gave us permission for delivery, again citing the cargo's dimensions and the increasingly complicated situation at the border. But we still managed to bring it to the United Arab Emirates.
In February 2023, the Ucarrat crossed the Belarusian-Lithuanian border on 2 trucks and was delivered to a container ship in the port of Klaipėda. The Baltic, the North, the Celtic, the Atlantic Ocean, the Mediterranean, the Red, the Arabian. The long journey across seas and oceans took almost another 40 days. And finally, the container with the valuable cargo arrives in the Persian Gulf at the shores of Sharjah.
After it arrived, we unpacked it and checked whether the marine environment had affected our vehicle. We made sure that it hadn't.
Zhenya, stop. The workers began installing the electric vehicle on the elevated track. After passing the intermediate tests, the entire complex is about to undergo its most difficult test. Only one step remains before the project is complete.
The most dangerous thing during transport tests, regardless of speed, is the vehicle derailing from the track structure. And the higher the speed, the more dangerous it becomes.
The control center for the test track in the United Arab Emirates. Three and a half tons of metal are being loaded into the unibus cabin. And now, its weight can probably be compared to that of a light tank. The testers are carrying out the final pre-launch checks. The result of the testing could be either a stunning success, comparable to the advent of the first railways, or a failure that would be far too costly. Any malfunction can be dangerous because of its consequences, which are sometimes unpredictable.
But as a rule, there is a clause in the contract stating that in the event of termination, it means that at our own expense, we must dismantle all our stations and terminals, demolish the track structure, pull out all the supports, haul everything far away to a landfill, and restore the land to its original state. There should be nothing but a wasteland there.
High-ranking officials from the Emirate of Sharjah have arrived. On one side, there are sheikhs ready to evaluate a new type of transport. On the other, engineers who must prove the viability of the technology. The control center gives the green light, and the massive steel machine begins to move. Dashcams are transmitting bird's-eye view images, but the technicians have no time to admire the scenery. They are completely absorbed in the testing process. Will the 12-ton unibus, assembled in Minsk, be able to reach a speed of 120 kilometers per hour on the track built in Sharjah?
When we accelerated using only the batteries, we couldn't reach a speed higher than 30 kilometers per hour. The problem with acceleration arose because there wasn't enough power for acceleration. And to increase the speed, we needed to supply additional power. We delivered this power through the rail. The left and right rails were positive and negative. The voltage was about 1,000 volts.
The technicians are gathering information. The speed and behavior of the car are monitored from the control center. The car successfully completes the test run. Despite all the difficulties, the uST team proved the viability of their technology. Construction is complete, opening up new horizons for passenger transportation.
We have provided for many safety options to ensure that there are no consequences, such as the vehicle running beyond the boundaries of the transport complex, to make sure none of that happens. I know it will run. That's what we designed everything for.
Even in the brightest future, there won't be a better system, because we're reaching the limits of what's possible according to the laws of physics.
The Ucarrat complex is a triumph of engineering thought. Its track stretches for more than 2 kilometers and has become the tallest and most load-bearing among all the company's projects. And the unibus literally flies over the sandy dunes of Sharjah, overtaking the flow of cars on the adjacent road. The implementation of the project has become a significant event. Delegations from 20 countries around the world have already visited here.
And I was traveling above the surface of the Earth. It was an absolutely new, unforgettable experience for me. When I was sitting inside, it felt as if I were sailing on a boat along the Nile. And there isn't that noise like in regular transport.
The time has come when we will travel above traffic jams and no longer wait at city traffic lights. We
were going very fast, almost 120 kilometers per hour. But inside you can hardly feel the speed. It's like being in a computer game or something like that. It's unlike any other form of transport.
What we're demonstrating, what we're doing, is showing that we've outpaced everyone else, and for good. To catch up with us, you'd have to repeat what we're doing.
Anatoly Unitsky was able to prove that the Ucarrat is capable of solving the problem of traffic jams in the extremely hot climate of the United Arab Emirates. The complex successfully passed the inspection and was recommended by the Dubai Roads and Transport Ministry for the construction of a 25-kilometer route in the city's tourist area. The demonstration of the Ucarrat sparked commercial interest not only in Dubai. India has chosen string transport to create a tourist crossing over one of the most picturesque and majestic waterfalls in the world. In one of the health resort areas of Eastern Europe, the Ucarrat will connect several buildings with a route through a pine forest, providing comfortable transportation for vacationers. In a coastal city on the Black Sea coast, the authorities are considering the Ucarrat as a convenient solution for transporting tourists from the airport to hotels and key attractions. In Rostov, this complex will help reduce traffic congestion by connecting the historic center with the left bank area, as well as the bus station with Platov International Airport. In Malaysia, the technology attracted the government's interest as an innovative solution for connecting hundreds of small islands, which would significantly simplify travel for local residents within the country. The Unitsky String Technologies team overcame the desert, the heat, bureaucracy, and technical challenges. They didn't just build the Ucarrat complex, they paved a new path for their company's future. What comes next? Will this technology be able to revolutionize the concept of passenger transport worldwide? The answer to that question lies in the future, which is already racing along the string rails.